throw, catch, and rescue. In Elixir, throw and catch are mechanisms to manually manage control flow, typically used in situations where typical error handling is not appropriate or when non-local return from a function is needed. They are less commonly used than idiomatic Elixir constructs like pattern matching and with statements. The code provided sets up a try block in which throw is used to intentionally exit the normal flow of execution by throwing a symbol. This is a throw. A catch block follows, which matches the thrown symbol and executes its associated code, returning the string, called a throw. It demonstrates how to catch a specific thrown value, rather than rescuing from an error, as in more common error handling. Errors and exceptions. In Elixir, you can raise an exception manually by using the raise function. Exceptions are raised when something goes wrong, and they can be rescued using try-rescue constructs. Below is an example where we raise a specific type of exception called runtime error. In the provided code, we define a module example that has a function testRaise. In this function, we use the raise function to intentionally create a runtime error with a message, "An error has occurred." When the function example.testRaise is called, the raise function causes the program to halt, and the error message is displayed unless it is rescued. Try, catch, and after clauses. In Elixir, error handling can be managed using try, catch, and after clauses. A try block executes code that may generate errors. A catch block captures and handles these errors. An after block ensures that cleanup code runs regardless of whether an error occurred. In the provided code, the try block contains a raise statement that intentionally throws an error. The rescue clause catches the runtime error and handles it by returning the string error handled. The after clause runs after the execution of the try block and rescue clause, regardless of the outcome, and it performs cleanup by printing cleaning up. This ensures proper resource management and cleanup activities. Using the with statement for composing. In Elixir, the with statement is used for combining multiple expressions that may return a success or an error. It's useful for cases where you want to perform a sequence of operations that could fail, and you want to handle the error as soon as it occurs. The with statement starts by evaluating operation 1. If it returns OK result 1, it proceeds to operation 2 result 1, and if that also succeeds, to operation 3 result 2. If all operations succeed, the final success value OK result 3 is returned. If any operation fails, i.e. returns a tuple starting with error, the evaluation stops and the do block is skipped. Instead, the code moves to the else block where the error tuple is matched and returned. This allows for a clean way to cascade error handling without deeply nested conditionals. Logging errors. In Elixir, logging errors is crucial for monitoring and debugging applications. Elixir's logger module provides built-in support for logging. It allows different levels of log messages: error, warn, info, and debug. We will use the logger.error/2 function to show how to log an error message. The code defines a module example with a function test logging that purposefully raises an exception. When the exception occurs, it is caught in the rescue block. Inside the rescue block, the logger.error/2 function logs the error message, including the exception details, using inspect. This logged information is useful for understanding the failure during the application's runtime. Quote and unquote. Quoting is the process of transforming Elixir code into its abstract syntax tree, AST, which is a nested tuple representation of the code. This is useful for macro creation and code analysis. The given code transforms the expression 42 plus 43 into its AST format. The AST for this expression would be plus context elixir import kernel 4243. This is a tuple where the first element is the operator as an atom, the second is the metadata, and the third is the list of arguments, also as ASTs if they're complex expressions. Macros. Macros in Elixir are a way to write code that generates code at compile time, allowing for powerful constructs like DSLs, domain-specific languages, and code that can dynamically adjust to its context. They work by taking AST abstract syntax tree as input and producing AST that gets injected into the module where the macro is called. In the code example, we define a module myMacros, which contains a macro sayHello. The macro takes a name, argument, and then uses quote to generate the AST representing a call to io.puts that prints hello, followed by the given name. When you import myMacros and invoke sayHelloWorld, it's as if you had directly written io.puts hello world at the place where the macro is called. The macro effectively injects code at compile time, resulting in runtime execution that prints the greeting. Domain-specific languages, DSL. Domain-specific languages, DSLs, are small languages tailored to a specific domain. In Elixir, we can use macros to create DSLs, leveraging Elixir's metaprogramming capabilities to extend the language in a way that is natural for a specific problem domain. The code defines a module event DSL, which contains a using macro. The macro defines two functions, create event and cancel event, inside the caller's module when use event DSL is called. This provides a simple DSL for creating and cancelling events. The quote block contains the code for the functions that get injected, while using allows the inclusion of the DSL in any module with the use event DSL directive. When create event or cancel event is called, it simply prints a message to the console. Hygienic macros. In Elixir, hygienic macros refer to macros that do not inadvertently affect the surrounding context by introducing unpinned variables or causing variable conflicts. Macros should maintain hygiene to prevent unexpected side effects or conflicts with variables defined in the macro user's code context. The macro myMacro is defined within myModule and contains a quoted expression that assigns a value to var and inspects it. Despite the same variable name, myMacro does not affect the var defined outside the macro. This is because when Elixir expands the macro in the caller's context, it automatically renames internal variables to avoid clashes, thus ensuring the macro is hygienic. When executed, inside macro will output inside macro, while outside macro will output outside macro, demonstrating that the macro did not leak its variable scope. Using macros for code generation. In Elixir, macros are compile-time constructs that allow you to generate code and inject it into your modules. They are a powerful tool for metaprogramming, enabling you to reduce repetition and create domain-specific languages. The code defines a module myMacros containing a macro sayHello, which takes name as an argument. The macro uses quote to generate the code that will be injected when called. In the greeter module, we require the myMacros module to make the macro available and invoke it passing the string world. When compiled, the greeter module will contain a line of code that prints hello world, even though we did not manually write the print statement in the greeter module. This demonstrates how you can generate code that runs at the application level using macros. Understanding protocols. In Elixir, a protocol is a means of achieving polymorphism. It allows different data types to share a common interface. For example, the string.chars protocol can be implemented for any type to define how it can be converted to a string. This code snippet defines a protocol printable with a function print that must be implemented by any type that wants to adhere to the printable protocol. It then provides two implementations of the printable protocol, one for lists and one for atoms, defining how each of these types should be printed. Finally, it demonstrates the usage of the print function for lists and atoms. Implementing protocols. In Elixir, a protocol is a means of achieving polymorphism by defining a set of functions that can be implemented for different data types. Implementing a protocol allows different types to share the same interface, with each type providing its own specific behavior for the protocol's functions. In the provided code example, a stringifiable protocol is defined with a single function toString that is expected to be implemented for any type that wants to be converted to a string. An implementation for the integer type is provided using defimple that simply delegates to the existing integer.toString/1 function of Elixir's standard library. This way, any integer can be treated as stringifiable. Understanding behaviors. In Elixir, behaviors are a way to define a set of functions that must be implemented by a module. This allows us to share a public API and have different implementations. Behaviors are similar to interfaces in object-oriented languages. The code defines a behavior parser with a callback parse, which is a function that accepts a string and returns a tuple. Then, it defines a module JSON parser that implements the behavior with a specific implementation of the parse function. By using the @behavior attribute, we instruct the compiler that JSON parser should provide all the functions defined as callbacks in parser, ensuring that the contract is fulfilled. Implementing callbacks. In Elixir, behaviors are a way to define a set of functions that has to be implemented by a module. This allows for polymorphism, where different modules can be used interchangeably if they implement the same behavior. Callbacks are the mechanism that behaviors use to specify which functions must be implemented. The given code defines a behavior, example behavior, with a callback perform task, which expects any type of arguments and should return a string. The module example implementation then implements this behavior. Using @behavior example behavior, it declares that it adheres to the defined behavior, and @impl example behavior provides a concrete implementation for the perform task function, showcasing behavior implementation and function callbacks. Using built-in protocols and behaviors. Elixir's built-in enumerable protocol is used to traverse data structures. Most collection types in Elixir implement this protocol. Let's take a look at how we can leverage the enum module to work with collections that implement the enumerable protocol. In this code, enum.map is a function provided by the enum module that operates on collections that implement the enumerable protocol. The collection list is passed to enum.map along with an anonymous function that squares each element. The enumerable protocol allows enum.map to traverse the collection and apply the function to each element. ExUnit Basics. ExUnit is the built-in test framework that ships with Elixir. It is a modular and flexible tool for testing your Elixir codebase. Before writing tests, ExUnit must be started, and this is usually done in the test.helper.exs file. Once started, you create test files with a test.exs suffix, which ExUnit will automatically discover and run. Writing test cases. In Elixir, we write test cases using ExUnit, which is a test framework that ships with Elixir. Each test case is a block of code that can assert expectations and will be automatically run and reported by the ExUnit command. To write a test case, we need to define a test module with use exunit.case, and then define our test cases with the test macro. This code defines a module called mathTest as an ExUnit test case. The async true allows tests in this module to run concurrently with others, as long as they don't share state. Inside the module, there are two tests. The first test asserts that 1 + 1 = 2, which should pass. The second test refutes that 1 + 1 = 3, meaning it asserts that this expression is false, and therefore this test should also pass. Assert and refute are macros used to confirm that code returns true and false, respectively. Test setup and teardown. In Elixir, ExUnit is the test framework that ships with the language. One of the features of ExUnit is the ability to set up common test context before each test runs, and also to tear down or clean up after each test. This is useful for ensuring that each test runs in a known state and doesn't affect the outcome of other tests. The code demonstrates how to use setup and teardown blocks in ExUnit. A setup block runs before each test and can pass a context to the test. Here, we're passing a map with a single key-value pair. Any test within the module has access to this context. The teardown block is where you can put any cleanup code. It runs after each test, whether the test passes or fails. Note that setup and teardown blocks are optional, and you only need to use them if you have common setup or cleanup code. Mocking in Elixir. In Elixir, mocking refers to the practice of simulating the behavior of real modules or functions in tests, allowing you to isolate the component being tested. A common tool for mocking in Elixir is the mocks library, which defines clearly how to create and use mocks in a structured way. The code defines a test module for an Elixir application using ExUnit and mocks. Use ExUnit.case async true allows for concurrent testing. The mocks functions setup, setMocks global, and setup verify on exit are used to prepare the mock environment. A mock module myapp.serviceMock is expected to receive a call to its function with any arguments, args, and is set to respond with expected response. Within the test, we assert that calling myapp.mymodule.callService yields expected response, which confirms the mock is working as intended. Doctests. In Elixir, Doctests provide a convenient way to write tests that are embedded within module documentation. They enable executable examples in your documentation, which helps to ensure that your code examples remain working and accurate over time. The example shows a simple Elixir module named math with a function add which sums two numbers. The module documentation @moduledoc and the function documentation @doc include code examples which are formatted as they would appear in the IEX Interactive Elixir shell. These examples demonstrate the usage of the add function, and they will be automatically tested when you run your test suite, provided you have set up Doctests in your test file using Doctest math. Writing documentation with ExDoc. ExDoc is a tool used in Elixir to generate HTML and EPUB documentation for Elixir projects. To add documentation to your code, you use inline doc strings marked by triple double quotes directly above function definitions. In the provided code snippet, ExDoc will generate HTML documentation from the module and function doc strings. The @module doc is used to document the module itself, providing an overview or description of its purpose. The @doc attribute is used to document specific functions, explaining what the function does or how to use it. ExDoc will parse these annotations and produce user-friendly documentation that can be navigated in a web browser. Creating projects with Mix. Mix is a build tool that ships with Elixir that provides tasks for creating, compiling, testing your application, managing its dependencies, and much more. Let's start by learning how to create a new project using Mix. The command mix new myapp creates a new Elixir project with the structure appropriate for a typical Mix project. It generates all the necessary files and directories for the project to get started. Myapp is the name of your new project, which will also be the name of the main module in your application. After running the command, you will have a new directory called myapp with a set of standard project files and directories within it. Managing dependencies. In Elixir, dependencies are managed in a Mix project by modifying the mix.xs file. These dependencies usually come from Hex, the package manager for the Erlang ecosystem. In this example, 3 dependencies are declared within the deps function in mix.exs. The atoms like Phoenix, Ecto, and Postgres are the package names, and the strings that follow, such as -1.5.7, specify the version requirements. The tilde arrow, chush, is known as the pessimistic version operator, used to limit the range of versions to ones that are expected to be compatible, allowing minor updates, but not major ones that could break compatibility. Mix tasks. Mix tasks are the building blocks that power the Mix tool in Elixir, used for creating, compiling, testing applications, managing dependencies, and more. Custom Mix tasks can be defined to extend functionalities for project-specific needs. This code defines a custom Mix task named hello. It defines a new module mix.tasks.hello and uses the Mix task behavior by the use macro. This provides the necessary functionality for defining a Mix task. The @shortDoc attribute is used to provide a brief description of the task. The run function is the callback that gets invoked when the task is run. In this case, it prints hello world to the console. To use this task, you'd save it in a file and run mix hello from the command line in your project directory. Environment configuration. In Elixir, different environments, like dev, test, and prod, can be managed with different configurations. Configurations are defined in config files within the config directory of your project. This code showcases how to define general application configurations that mix with environment-specific settings. Using hashed mix.n interpolates the current environment name into the database configuration, allowing dynamic database names based on the environment. Then there's a default API key configuration. Lastly, environment-specific configurations are imported from corresponding files like dev.xs, test.xs, or prod.exs, which allows overriding and providing specific settings per environment. Project compilation. In Elixir, project compilation refers to the process of converting source code files into bytecode that the Beam, Erlang virtual machine, can execute. Mix is the build tool used to manage this process. The code defines a simple Elixir module named myapp, which outputs a string when it's being compiled. Mix would handle the compilation of this module and any other module in the project, generating the corresponding bytecode files. The mix compile command triggers this process explicitly. Releases with Distillery or Elixir's release. Releases are a way to package Elixir applications into self-contained directories that are ready for deployment. Before Elixir 1.9, Distillery was a widely used tool for creating releases. It provides tasks for assembling a release and configuring it at runtime. This command runs the mix task provided by Distillery to create a release for a production environment. It will compile and bundle the application code, its dependencies, the Elixir runtime, and any configured applications. The output is a release directory with executables.